All right. If you're building anything with LLMs right now, you know things are moving fast. Today, we're diving into a really big one, a foundational upgrade. We're talking about migrating away from the chat completions API that we all know over to something new called the Open Responses specification. And trust me, this is way more than just a little syntax change. It's a completely new way to think about building AI agents.
So let's just get right to it. Is the chat completions API hitting a wall? I mean, think about it. As the agents we're building get more and more complex, haven't you started to feel the friction? Like, if you've ever spent hours wrestling with state management or trying to debug a complex tool use loop, yeah, you know exactly what I'm talking about.
And yeah, those pain points are very real. First, that costly context replay. You know the drill. Every single turn, you have to resend the entire conversation history. Your token bill just goes through the roof. Then there's the tool orchestration. It just feels clunky, right? It's error-prone, and the whole thing is built on this rigid, monolithic message structure. And maybe the worst part? That vendor lock-in. You build for one API, you're stuck with it. It is definitely time for an upgrade.
Okay, so here's our game plan for today. We're going to walk through this whole upgrade step by step. We'll start with the limits of the old API just to really set the stage. Then we'll jump into this new agentic paradigm. From there, we'll get into the nitty-gritty, moving from messages to items, and what the code migration actually looks like. And then the fun part, the payoff, why this all leads to better agents. And we'll wrap up by looking at why the future is all about being interoperable. All right, let's kick things off by digging into the core problem with the Chat Completions API. And really, it all boils down to one thing. It's stateless model. So what does stateless actually mean in this context? Well, it's pretty simple and pretty painful. It means that every single time your app makes a request, you have to send the entire conversation history along with it. Every single time. In a production app with a long conversation, this gets brutal. You're making these massive API calls. You're literally paying for the same tokens again and again. And your users, they're just sitting there waiting for a response. It's slow and it's expensive.
Okay, so that brings us to the new way of thinking, the Open Responses specification. Look, this isn't just a Band-Aid fix, it's a total rethink of how we interact with these models. It's all built on these three big ideas: items, state, and interoperability. And this right here is probably the biggest mental shift you'll have to make. We're getting rid of that one-size-fits-all message object. Instead, the basic unit of conversation is now an item. And the key here is that these items are polymorphic. They're strongly typed. So a piece of text is one type of item. A tool call is another type of item. A tool's output, that's its own separate item too. It brings a ton of structure and clarity, where before there was just a blob of text. And check this out. This slide just lays it out so clearly. On the left, that's the world we live in now, sending the whole giant conversation history every single time. But look at the right. That's the new stateful workflow. After that first API call, all you send back is this tiny little pointer, a previous response ID. That's it. The server takes care of the context, and boom, you've just unlocked huge performance gains and serious cost savings. All right, let's get into the weeds a bit. We're going to deconstruct the new schema and see how this whole item concept actually looks in the JSON you'll be sending and receiving.
Okay, this table is super important. It's basically our Rosetta Stone for this migration. Let's walk through it. First, see how the messages array is now an input array? And inside, instead of just a generic content string, you have a specific item with type input_text. But here's the really big deal. Look at tool usage. Tool calls isn't some property buried in a message anymore. It's a first-class citizen, a function call item. Same for the results. They're a function call output item. Just this one change makes building agentic loops so much cleaner and way less buggy. Now, this is a small change in the spec, but it has huge security implications. The old system role is gone, and in its place, we have the developer role. This isn't just a name change. Instructions you provide in the developer role have a higher precedence. What does that mean? It means it's much, much harder for a malicious user to prompt inject your agent and make it ignore its core programming. It's a really smart security boost. Okay, time to roll up our sleeves. Let's talk about the code. Honestly, the most hands-on, heavy-lifting part of this whole migration is probably going to be rewriting your streaming parser. We're moving away from simple chunks of data to a full-on event-driven protocol. So instead of getting these generic delta chunks, you're now getting named semantic events, things like response.output_text.delta. Super clear. But the real game changer here, the one you should get excited about, is this new event, response.outputItem.added. Think about what this means. This event fires the second the model decides it's going to, say, call a function, before it has even generated the arguments. For your UI, this is gold. You can instantly pop up a running tool indicator or a skeleton loader. No more waiting, no more awkward flashes of content. It just makes for a much smoother, more professional user experience. So, how do you actually build a parser for this? It's a pretty clear four-step process. First, you listen for that output item.added event. That gives you the item's type and its unique ID. Step 2, you immediately create a UI skeleton, that running tool thing we just talked about. Step 3, as the Delta events stream in, you just append them to a buffer that's tied to that item's ID. And finally, step 4, when you get the output item.done event, you finalize everything and update the UI with the complete content. Yeah, it's a little state machine, but it's way more powerful and predictable than what we had before.
Okay, so we've done all this work, rewriting our parser and changing our schemas. What's the payoff? Well, this is the good part. This is where all that effort translates into real-world benefits. Faster, cheaper, and way more capable agents. Just look at that number, 40 to 80%. That's the estimated cost savings you're looking at for long context tasks. How? Because now that the server manages state, providers can do something called prompt caching. They don't have to reprocess that whole conversation history every single time. For any application at scale, a 40 to 80% cost reduction isn't just nice, it's a massive, massive win.
And it's not just about cost. Your actual agent logic gets a serious upgrade in robustness. Because function call and function call output are now their own separate items, and they're explicitly linked with a call ID, you get to wave goodbye to a whole category of frustrating lost context bugs. You know, the ones where the model gets confused halfway through a complex tool use chain? Gone. It just makes building reliable, multi-step agents so much less painful. And this even paves the way for things like hosted tools, where the server can just run the tool for you. Imagine how much that simplifies your client code.
And finally, let's zoom out and talk about the big picture. Why is the open and open responses so important? It's all about breaking free from vendor lock-in and building a truly portable ecosystem for our apps. See, because this is a standard schema, you can write your application logic once. Then you can have something like an open responses router in the middle. This router's only job is to take your standard request and translate it into whatever the backend model provider needs. Whether you're hitting OpenAI, Anthropic, or even a local model running with VLLM, your code doesn't have to change. Your app becomes model agnostic. And that is true flexibility. This quote from the technical report really nails it. This whole migration, it isn't just about fixing the annoying things about the old API. It's about laying a new foundation. A foundation for the next generation of AI apps. The truly autonomous, multi-step, multimodal agents that we're all dreaming of building.
Okay, so let's wrap this up with a quick checklist. What are the critical steps for this migration? First, update your schema. Replace messages with typed input items. Second, harden your tool definitions with strict JSON schemas. Third, and this is the big one, rewrite your streaming logic for the new semantic events. Fourth, start using previous_response ID to manage state. And finally, update your error handling to look for new statuses on a per-item basis, like refusal.
Look, this whole migration is a huge step forward for everyone building in this space. It gives us the tools we've been asking for, tools that are robust, efficient, and interoperable, so we can finally push the boundaries of what's possible. The foundation for the future of AI agents is being laid right now. So really, the only question left is, what are you going to build with it? I, for one, can't wait to see. Thanks for watching.